All right, today we are going to learn our third and final method of solving a system of linear equations. This method is called the elimination method. So if you review with me here, we started off with the graphing method. And the way that we solve using the graphing method is we graph both lines, and where they cross, that's my solution. Then the last couple days, we have been doing the substitution method. And the way that we do that is we substitute, solve. Okay? And then here we are going to do the elimination method. So when you think of that word eliminate, our goal is to try and get one of our variables to cancel out as we're working through. So the steps that we are going to use to solve the elimination method is, number one, we are going to make sure that the equation is lined up into columns. We should have an x column, a y column, an equal column, and a constant. This is what it should look like. So if you look, you should have a column going down with your x's. You should have a column for your y's, a column for your equals, a column for your constants. So they should be right on top of each other. Then what we're going to look for is that one of our variables will have opposite numbers, opposite coefficients. So if you don't, what you can do is you can multiply to get them both to be opposites. You might have to multiply one equation or both equations to do this. On day one today, we're going to do at most one equation. Then what we simply do is we're going to add down the columns. We're going to solve that new equation that's left. We're going to substitute that back into one of the equations for that variable. We're going to solve for the other variable, and then our answer will be the ordered pair x comma y. All right, so let's give this a shot. So if you look, starting off, I look at this and I say, okay, are my variables in their columns? So if you notice, I have my x column, I have my y column, my equals are on top of each other, my constants are on top. So then the next thing I look at is I look at each individual variable. So let's start with the x's. On the x's are the coefficients, negative 10 and 10, are those opposites of each other? And the answer would be yes. So what that tells me is I don't have to multiply in this problem. So instead, I'm just going to add. So when I add down the columns, I get negative 10x plus 10x, that's 0. Negative 4y plus 9y, that would be 5y. And then 0 plus negative 25 would get me negative 25. At that point then, I'm going to take and I'm going to divide by 5. When I do that, I get y equals negative 5. Then I take this, negative 5, and I'm going to plug it back in for y. So I'm just going to pick the first one. You could do the second one also. It would get you the same answer. So if we plug that in, it would say this, negative 10x minus 4 times negative 5 equals 0. So at this now, we go negative 10x plus 20 equals 0. I'm going to minus 20 from both sides. That's going to give me negative 10x equals negative 20. Then at that, I'm going to divide by negative 10. And I get x equals 2. So my final solution then would be 2 comma negative 5. Now, just like in all the other methods, we can also check that answer by simply plugging the 2 in for the x, the negative 5 in for the y, and it should work out to give me that solution. So let's try it. So if I go negative 10 times 2, that's negative 20. Negative 4 times negative 5, that's a positive 20. So negative 20 plus a positive 20, that equals 0. Worked in the first equation. Now let's try the second. So I'm going to go 10 times 2 is 20. 9 times negative 5 is negative 45. 20 plus negative 45 gives me negative 25. So what that tells me is I did this correctly, and this is my solution. All right, let's try this second one then. Now, when we look at this second one, if you notice, you have x's, you have a 6 and a 4. So we're not going to mess with my x's. But if I look at my y's, I have negative 5 and negative 5 for their coefficients. So if I could multiply one of those equations by -1, it would make it to be an opposite of -5, which would make it back to being a +5. So what I'm going to do is I'm going to take this first equation, and I am simply going to multiply by a -1 to each item in that equation. So here's what I now have. So what I'm going to do is -1 times -6x gives me 6x. -1 times -5y gives me a +5y. -1 times -4, that gets me a +4. Then I'm going to bring down my second equation. And now I'm simply going to add 6x plus 4x, that's 10x. My 5y's, they would cancel each other. 4 plus 16 gives me 20. At that now, I'm going to divide by 10, and I end up with x equals 2. Now I take that, and I'm going to plug that in for the x. So when I work that out now, I'm going to go 4 times 2 minus 5y equals 16. So 4 times 2 is 8. 8 minus 5y is 16. Now I'm going to subtract 8 from both sides. That's going to get me -5y equals 8. I'm going to divide by -5, and that would get me y is equal to -8/5. So my solution would be 2, -8/5. Okay? Now, this one did come out as a fractional answer for y. Now, I did that just so you see that these can come out with fractions. Most of the problems that we do in this class are not going to have a fractional base, but I just want you to understand these can come out to be as fractions as well. Okay, so let's try number 3. Now, when I look at number 3, the first thing I notice is that none of my numbers are the same. I have on the x's, I have a 6 and a -2. On my y's, I have -2 and a 4. So what I'm going to do is I need to multiply one of those equations by a number to make it be the opposite of the other equation. So for example, I'm going to get my x's to cancel. So I look at this and I say, okay, what can I multiply to -2 to make it be the same as 6, but it's opposite? So in other words, -2 times what would equal -6? And that answer would be times 3. So I'm going to take that 3 and I'm going to multiply it to each one of those. So what that now gives me is 6x minus 2y equals 16. Then I multiply by the 3 and I get -6x plus 12y equals -6. At that now I'm ready to add. So 6x plus a -6x, those are gone. -2y plus 12y, that gives me 10y. 16 plus a -6, that gives me 10. I take that, I divide by 10, and I get y equals 1. Okay, now we take that value of 1, and I'm going to plug it in. I'm just going to go to that first equation. So I have 6x minus 2 times 1 equals 16. So 6x minus 2 equals 16. I'm going to add my 2 to both sides, and I get 6x equals 18. I'm going to divide by 6, x equals 3. So my solution to this equation is going to be 3, 1. And that would be my solution for that. Okay, let's try this last one. So if we look at this last one, I have an 8 and a -6. And that I can't multiply just one of them by something. And then on the other one, I have -2 and -10. So what do I multiply -2 by to make it equal a +10? Because I need it to be the same number, but the opposite. So we are going to multiply the top equation by -5. Now, make sure that we multiply all parts of that equation by -5. So when I do that, I would get -40x plus 10y, and that equals -100. And then in the second equation, I get -6x minus 10y equals 8. So now I'm going to add those equations. So negative 40x plus a negative 6x gives me negative 46x. I have 10y plus a negative 10y, that's 0. Negative 100 plus 8, that's going to give me negative 92. At that now, I'm going to divide by negative 46. And I end up with x equals positive 2. I now take that and I'm going to plug it into x. I'm just going to go into that first equation. So 8 times 2 minus 2y equals 20. So 8 times 2 is 16. At that now, I'm going to minus my 16. And that gives me 4. I take that, I divide by negative 2, and I get y equals negative 2. So my solution would be 2, negative 2. And that is how we solve a system of linear equations by elimination.